Hey everyone, welcome to this channel. Today we're building a real-world CCNA lab together, one that's going to help you actually understand segmentation, ACLs, DHCP, NAT, and port security instead of just memorizing commands on the exam. Before we jump in, this lab file is completely free and waiting for you in our community CCNA gym. All you need to do is sign up. It's free, no catch. CCNA Gym exists to help people preparing for the CCNA actually get the material, not just memorizing stuff. And just as importantly, it's a place where you don't have to go through this journey alone. You'll find other people on the same path, ready to help each other out, share wins, and keep each other motivated when things get tough. So go grab the lab file, drop it into Packet Tracer, and configure along with me. Let's get into it. Quick look at the topology before we jump into the CLI. We've got router 1 acting as a router on a stick. One physical interface carrying multiple VLANs through subinterfaces. Behind it sits switch 1, our distribution switch, trunked to switch 2, our access switch. Hanging off switch 2 are our end devices, 2 PCs in the sales VLAN, 1 PC and 1 server in the IT VLAN. We are working with 3 VLANs here. VLAN 10 for sales, VLAN 20 for IT, and VLAN 99 for management. R1 also has a WAN interface facing the internet at 203.0.113.1/30. Let's start on router 1. The sales sub interface is already there in your starting config, but the IT one is missing. Let's add it now. Pause the video if you need to, then type this in with me. So, enable conft interface g01.20 to enter the subinterface config. Description IT VLAN. Encapsulation .1q20. IP address 192.168.20.1 and the subnet mask is 255.255.255.0. And don't forget IP NAT inside. That's what makes NAT apply to this network later on. Important detail here, the encapsulation.1q20 has to match the VLAN ID exactly on the switch side. Otherwise, inter-VLAN routing simply won't work. Alright, exit. Now, task 2 is to create a DHCP pool for the IT VLAN. By the way, I think I forgot to mention it, you will find all the tasks and also the IP information or IP address information inside the community as well. Alright, next, our IT clients need automatic IP addressing. The sales pool already exists in our config, now we build the IT one. IP DHCP pool IT_pool network 192.168.20.0 with a subnet mask of 255.255.255.0. Default router is going to be 192.168.20.1. And for the DNS server, we're going to use 8.8.8.8. Alright, that's it for the DHCP pool. We can exit this configuration context. Now, for our internal clients to reach the internet, we need NAT overload. That part's already set up. What's missing is the access list that defines exactly which networks are allowed to be NATed. So we need to create a NAT ACL. So we're going to type in IP access list standard NAT_ACL. Now we want to permit both of our internal VLANs, sales and IT. So we're going to enter permit 192.168.10.0, which is our sales VLAN. Now we have to enter the wildcat mask, which in our case is 0.0.0.255. Then we're going to do the same thing with the IT VLAN. So we just have to replace the 10 with a 20 here in a third octet. Enter. And that's basically it. And this is, by the way, a standard ACL because we are only filtering on source IP. We don't need port or destination info here. The NAT statement itself is already sitting in your config and will now automatically reference this new ACL. Alright, next task. Now for the most interesting part. We want sales to be able to ping the IT server for troubleshooting purposes, but nothing else. At the same time, sales still needs full access to the internet and everything else on the network. For this, we need an extended ACL because we have to filter based on source, destination, and protocol. So let's create an extended ACL. IP access list, extended, and now the name of the ACL, which is going to be sales _to _server _restrict. Enter. First, we permit ICMP from sales to the server. That's our ping traffic. So permit ICMP 192.168.10.0, which is our sales VLAN. Then the wildcat mask 0.0.0.255. Then we specify the host we want to reach, which in our case is the server. So we type in 192.168.20.100. Second, we deny all other IP traffic from sales to that exact host. This blocks HTTP, Telnet, SSH, everything except ping. So deny IP 192.168.10.0. Our wildcat mask 0.0.0.255. Host third, and this is critical, we permit IP any at the end, so all other traffic, including internet access, still flows normally. Permit IP any. Keep in mind, order matters here. ACLs are processed top to bottom, and once a match is found, processing stops. If you put the deny statement first, you would block ping 2, so keep this exact order. Now let's apply it. We'll apply it inbound on the sales sub interface, since we want to catch this traffic as it enters the router from the sales VLAN. Interface gigabit 0.1.10 for the sales sub interface. IP access group sales _to _server _restrict in. Alright, that's it for this part. Let's move over to switch 2 now. Switch 2 is our access switch. We want to make sure that if someone unplugs a PC and plugs in their own laptop or tries to flood the port with random MAC addresses, the ports shut down automatically. So let's type in enable conf t, and then we want to reference ports fast Ethernet 0, 1 to 4. So we're going to type in interface range fast Ethernet 0/1 to 4, like this. Now we want to enable switch port security. switch port security maximum 1, switch port security MAC address sticky, and switch port security violation, port security violation shutdown. A quick breakdown here. Maximum 1 means only one MAC address is allowed to be learned per port. Sticky means that the switch dynamically learns that MAC address and saves it into the running config automatically, so we don't have to type it in manually. And violation shutdown means if a second device tries to connect, the port goes into error disabled state immediately. Now for the last step on switch 2, best practice is to shut down every port that isn't in use, so nobody can just walk up and plug into an open port. So we will now reference all the other ports on the switch. Interface range fast Ethernet 05 to 24. Shut down. It's simple, but it's one of those small details that makes a real difference in a real network. Now let's verify everything actually works. First, we want to confirm that PC Sales 1 received an IP address from the sales VLAN via DHCP. So on PC Sales 1, let's open the command prompt and type in ipconfig. Here you can see that it actually received an IP address from the correct VLAN. So this one is working. Now let's head over to PC IT1. Let's open the command prompt tool and enter ipconfig. And we can see that the PC received an IP address from the IT VLAN. So this is working too. Now the important test. From sales, ping the server. This should succeed. So ping 192.168.20.100. First ping times out because of ARP, and the subsequent ones succeed. Now let's try something that should fail. Try to reach the server via a telnet session. Type in telnet 192.168.20.100. This should eventually time out. Yep, and that confirms that our extended ACL is working exactly as intended. Ping is allowed, while everything else is blocked. Finally, let's confirm internet access still works from sales. Try pinging the ISP router interface. Ping 203.0.113.1. 2. First one timed out because of ARP again, and the subsequent ones are working. And on R1, let's double check our NAT translations are actually happening. Let's type in show IP NAT translations. Perfect, so you can see that our Sales 1 PC's IP address being translated to our outside interface address, which is this one. And that's it. You've just segmented a real corporate network, restricted access between departments, secured your switch ports, and got NAT and DHCP running end to end. This is exactly the kind of scenario you could run into on the job, and the exact kind of thinking the CCNA exam wants to see from you. If you got stuck anywhere or want to compare your final config, head over to the CCNA gym. Post your questions there and let's figure it out together. That's what the community is for. See you guys in the next lab.